Hello everyone, nice to see you again. I'm Chris. In this video, I very happy that I can borrow a device from Schmersal that is a SFB-EC-8M12-IOP. So in this video, I prepare a trinket runtime with 4026 that and a EL6910 to configure a ESAC FSoE network and then to connect to this module. And I also connect to some eStop and Light Garden. Okay, I hope you like this video. Let's go. Before I continue the video, let me introduce myself again. I'm Chris. I come from Hong Kong. Now I'm working some stuff in factory automations. In the left-hand side, in the left-hand corner, that you can see my Twitter, my YouTube, my blog, and I started a radio channel. It's called FA Radio. That if you like it or interesting about that, please click on it and to find more information about that. Okay, so more of the information is I screenshot or captured from the Schmersal's menu, but I give you a very rough conclusions of what this module is, what it can do. So as you see, this is the Schmersal module's layout, and this this module have 2 safety input and 2 test pulse outputs. It provides dry contacts on each of 8 ports from X0 to X7. And then you have P types. So the first type is 1 channel safety switch with dry contact, and 2 channel safety with dry NC contact, and 2 safety switch with 24 volt PNP solenoid stated output or SSD. And then the SFB, this module, also have a safety digital output on 8 device port 0 to port 7 to control the load up to 0.8 ampere. The safety digital outputs on port 0 to port 7 to control loads up to 0.8 ampere and convertible safety signals. You have 2 modes for allow you to set it. The first one is safety output with 1 wire and safety output with 2 wires. And then we have this module have a 1 diagnostic input for each of 8 device port. So from X0 to X7, they have this status for you to know that this port mode now is passive or not, or have any error clock or something. Okay, as we mentioned before, that this module is SFB-EC, EC-8M12-IOP. So in the EC-8M module that we also configure as a FSoE slave. So fail-safe over EC-8M is a functionality safety extension of the standard communication with EC-8M. Communication based on FSoE are safety against and for the transmission error and missing efficiency and if any loss of inside your telegrams. And the safety field box, this module is an FSoE slave in the EC-8M network. And the module accepts a safety communication with the FSoE master and then transfer the safe data with FSoE and the function data with EC-8M. So here is an example that you can see this Lego low icon is I think is a moving image a CX controller from Beckhoff, or you can use a EC-8M coupler in my case. In this tutorial I use a EC-8M couplers, and then you can connect to the or this Schmersal module by linear, and then here you need to have a FSoE master, for example EL6910 or something. Here is a system layer example that to show you how to use Schmersal in your safety system. And so this station is I mentioned in the last slide, and then all this network is connected linear one by one. And over here you can connect your safety switch, door lock, and safety relay or light guard, everything that you liked. Okay, as I mentioned before, that this module you can configure the input or output to each mode, and Schmersal have 4 modes allow you to configure. They have type A, B, C, and D. And then in this screen you can see that this is a screen I captured from TrinSafe. Then you can configure each board to mode A, B, C, D. And then for the parameter set A, mode A is a safety monitor 1 to 2. It's a cross fault detection off and safety gear switch gear handling the cross fault detections. And the type B is very similar to type 1, but it have 2 channels for OSSD output and the electrical sonic interlock, and the 2-wire control for the unlock functions. And for type C is the safety monitor for 1 to 2. It have the cross for detections, and it's a drive contact. And Type C is very similar to Type D, but it's not 1 to 2. It's a 1 by 1. The signal is monitored by 1 by 1. So you need to be take careful because this Schmersal module is using a 8-pin M12, and here is just specifications that what the pin assignment of this module, and also for the power cable they're using T-code. So if you need to use this module, please buy the suitable cable from Schmersal or any cable supplier. And here is the application that I would like to show in this time. And sure, for I use Beckhoff.Let to configure as a EC-8M FSoE master and to communicate with this safety module. And in this module I use port X7 and X5 to connect the E-stop and the LiDAR garden. And sure, you need to configure FSoE network. You need to download the EXI file from Schmersal's homepage, and then in this tutorial I'm using Trinket for 0.2.6. So we need to put the ESI file to the C program file 6 x86 Beckhoff Trinket 3.1 config IO and ESI this directory. And also don't forget to set the FSoE address. It's very important. And after there is a router switch that on the module that you can configure your FSoE address. And then here is a screenshot in the TrinSafe. Then you need to match FSoE address. For example, in this case I set to 10, so in the router switch you also need to set 10. And you can also have a EOE functions. In this module is the Ethernet over EtherCAT. If you activate these functions, then you can access the web server inside this module. In the web server, you can know that the module status, you can know the parameters, you can know the error code or everything that you need to know when you have an error. Okay, so I think my short explanation here is enough. Now I will turn on my camera, then let's see what kind of demo that I will actually show you in this tutorial. Okay, now I turn on the camera, then I will show you the hardware that I'm using this time and give a very rough instructions. So here in the left hand side is a small safety device training kits that I made by myself. In here you can see the door lock and LiDAR garden and the E-stop and one push button. And this right hand side, this is the module they're using this time is Schmersal's FSoE slave IO block, and here is the EtherCAT coupler from Beckhoff, and here is the FSoE master EF6910. So with this board I'm connecting to the I think it's connecting to the emergency stop, and X5 will be connect to the LiDAR garden. And I will show you this simple operations of this tutorial. So when I put my hand into the LiDAR garden, and the light and the E-stop output will be turned off. And also when I press the E-stop button, the E-stop light will also be turned on. So let's see it. Okay, as you see, this is just a very simple demo, but I will open the Trinket to show you how to configure it step by step. Okay, so let's start. Okay, now we open our Trinket project, and here is 4026 version. So the first of all, I will add a EtherCAT driver. So go to okay, where is my mouse? Let me see. Okay, here's my mouse. And IO, go to IO, device, right click, add new system, and EtherCAT master. So I always put the LAN here, and then I will click on the EtherCAT and go to search in the adapter tab. Then you can choose the Ethernet interface that you would like to use as a EtherCAT master. So in my case, I will be this one, controller sharp 2. And after you choose the address and the adapter, then you can see the IP address and the MAC address. So you can need to make sure that you are using the correct interface. Okay, Then we can close it. Then we use the scan functions. Is a very great. Right click and scanned. And then we can get the EC-8 coupler from Beckhoff and also the Schmersal IO block. So just open here. Then here we have our EL6910, and also here you have our Schmersal IO block, and have 4 byte in output and function data and I data, etc. Okay, so first part is finished. Now we can add a PLC project. Go to PLC, right click, add new items, choose standard PLC project, press OK, press add, and you add a PLC project in here. So the first one, I will create some data type. The first one will be 8-bit device. Great. Then just create some bit for that. PX PX01, PX02, PX03, PX04, PX05. Need some time. I don't know why, because my computer seems to be slow. Okay, it works. 05 and PX06, PX07, and all is in bit type data type. It works. Okay, and then I will add a dynamic data type. Its spelling is SFB. SFB is mean the safety function module or safety function device something, and then DIA dynamics, DIA-GNOS-IS data. Great. Okay, so need to be big. And then fork flag module. So you can reference the manual there to see a little bit more for each device meaning. So in here I will not explain too much. I'll just devise it. The device port and forward flag COM-FB interface. So bit type, and then I have a dynamics DIAGNOSITIC data VALID. Also a bit data type, and I have a request ACK, also a bit data type. It works. Okay, then we can define our global data types, a global label list, and just add it and open it and submit it to be big. Okay, first of all, I'll define a run at %q star mark bool. Okay, and now I have a at %q star mark and also bool. These two variable is for the safety, to activate the safety group, and also for send a reset signal to the safety group. I mean in the EL6910. And then we have a SFB port Q QUALIFIER at %I DUT 8 bits. That was the data types we defined before. Then we have SFB DIAGNOSIS data at %I. This one I think is SFB direct data. Great. And I will define error code, because I also can get the error code from with EC-8. I is mean it's USINT. Okay, and I have a SFB ACK. It will be also it will be its output. It is the global signal, global reset signal from the TwinCAT to the Schmersal module. Okay, okay, great. Then we can build it. Go to build solutions. Okay, great. It means that no error. Then we can create some small program. Okay, so the first one I will define some variables for me to reset the Schmersal module. X on is mean bool. Great. And then I have a T on. And then GVL.SB ACK is equal to X on. And then I have a T on 1. I is equal to X on. And PT is equal to T sharp 500 millisecond. And if T on 1 dot Q, it means the timer is reached 500 millisecond, I will turn off the X on bit again. Very simple, no difficult things. Just build one more time, make sure no error. Okay, then we can download the project, the normal Trinket project, to our Trinket runtime. Go to plus activate conversions. Okay. And okay. Okay. Oops, I forgot something. Sorry, I forgot to map the signal. Okay, so let this to change the save to the run mode. Okay, and this is run mode, no error, no setting error. Then we can do some mapping. For example, here this one is functional data to the port qualifiers. Select all, right click, change multiple link, and then choose the data the variables we defined before, and then do the same thing for the dynamic data. And I'll click here and then select all and change link, port module, device port. This one is the FB.com, and for request egg. Okay, and then I also need to define the reset. Do the same thing, change link. Let's do this SFB arc, and then do the same thing for error code and SFB error code. Okay, all the mapping is done. Let me download again. Great. Turn to run mode. Okay, it needs some time. Then we're going to log in, and they're going to play. Now our Trinket is in run mode. So, and the next step, we can configure our safety project. Go to safety and right click, add new items. There are a couple templates that Beckhoff is provided for you default. I always use this, the first one, pconfig error arc. So let's add it, and then use hardware software PLC and press OK. And the safety project is created in your whole solution project. The first one you need to set is the target system. So the target system is mean that what is your FSoE master in here. Go to click it, and you have different types because you have so many types of safety PLC that's come from Beckhoff. But in this case, we are using EL6910. So let's click on the drop down list, and then choose 6910, and then choose the plus button, and then choose which one, which terminal they would like to use. You need to use in the EC8 network. In this time, only have one EL610, so choose it. Okay, and then you see the serial number and the FSoE address is mapped directly upload from the module. Okay, we can save it. The next part we need to is to add some alignment device. So go to safety group 1, and then alignment device, and the right click, add new items. So I think that we import the ESI file to the Trinket runtime. So in Trinket element. So in the safety, EC8 and Schmersal. Then you have this FSoE 4-byte in out from Schmersal. Just add it, and then click it. You need to set the FSO address. I set the FSO address to 10 by using the router switch. So just press 10, and then press click the plus button to choose which module is using is for this alignment device. In this case, I only have one, so press it, save it. Okay, and then all this signal all these parameter will be automatically get from Trinket. And then the next step is we need to configure the connections. So actually no need to configure too much in here. Just make sure that your connection ID is unique and don't duplicate your other device. The safety parameters we need to change something, because for the X7 we use a try contact to connect to a emergency stop. So go to here, choose C. Okay, and then it works. Okay, so the next step is we need to define the run signal to receive the run signal from TwinCAD runtime to activate our safety group. Go to alignments, add new items, and then choose standards, one digital input. Then you need to change the name of this one. I will change run, and then click on it, and then press the link to, and choose the GL.1 is the variables you define in TwinCAD PLC project. Do the same thing for the error acknowledgement. Okay, just click the plus button, GL.ack. Great. Okay, so now the next step is to create a global safety global variable list. Right click, global variable list, and then you can click the plus button to add some variables. So before that, I'll just close all other thing not used. Go over this. Oh, why? Okay. Close. Close. Okay, just close. Okay, and then press G again. Click plus button. The first one will be GX7 E-stop. And then for the alignments, what I'm using is the X7, X1 and 2. And then I'll add one more device, GX7 output. For the usage, I will use this X7's output port. Okay, great. And then I have a run signal, G run. Then link to the run signal that we defined before. Then final, we will have a OSSD, GX5 OSSD. And then here will be X5, X1 and X2. Okay, great. Okay, we finished the basic mapping. Then now we can start to do our safety program. Go to TwinSafe, TwinSafe group. You need some time to open the program. I mean, because my small PC is not very fast. Okay, then in the toolbox, then you have so many safety components come from Beckhoff. Then you can use them for program your own safety system. But in this tutorial, I just do some simple way. So the first one, I use the safety decouple. Okay. Oops, wrong. Safety decouple is this one. Yeah. This one. Drop it, and then change link. Okay. And then I will the 7 stop, and the second one is the OSSD. And then in the right hand side, I'll add some variables. This for local X7 E-stop. Okay, then I'll add a timer for the lighter garden. So I will put a safety timer in here, and I'll set the time to 1 second. Then I'll drop the output to the safety timer, and then here I'll add a new variable. It's called X5 OSSD. Great. And then I'll add a new network. Right click, add after network. And I'll use a N block. So safety N. Where is my safety N? Where's here? Okay. Then drop it. And then right click, change link is oops. I think I did. Okay. And first one is E-stop, and the second one is OSSD. Okay. Then for the output, I'll add one more variables, x7 output. Okay, and then I will drop one more. I add one more network, add after. Okay, and then I'll use save the couple again. Then for this input, it should be here, not grun, x7 output. Then I will turn the output to the gx7 output. Great, it's just like this. Okay, and then what we need to do is to map the run stop signal. You'll be found in the variable mapping and group port, and you have a run stop. Click on it, and then open it to choose grun. It works. And then finally, we can press this check button to verify our safety project. I think it will be not error. Yeah, no error. And then we can download the project by press this button, download safety project. Then for the username, the default is administrator, so admin_istrator. Then we will have a serial number, the number that is printed on my EF670 11981 I think it's not correct. No, wrong. It's correct. Then for the password, it's TwinSafe. Great. It should work, I think. Yeah, complete data. Yes, next. And then I have a menu check. Enter the password again, TwinSafe. Okay, great. Then I think the TwinSafe project is also run again. It's also running. We can go to G arrow. I think it needs some time. Just a second. Let me close all stuff that we don't need. Okay, here is our PLC program. And here is our global variable list. Then I will press run. Then I press egg. Then also plus the system egg. Oops, here is here. Okay. Did I press it? Okay, I think I pressed all the data. So I think we can go to the safety group. You need some time to open the project. And then go to monitor. You need some time, I think. Second, why I cannot monitor it? I think I need to download it. I think I downloaded this, right? Let me download again. Okay. Let me download again. Yes. TRATOR. Okay. TwinSafe. Okay. And then next, I'm gonna download the project. And then next, and I menu it, and then download, check the project again, enter the password again. Okay. Now it should be run, and just wait a second. Let me download this project again. Otherwise, it doesn't work. Yes. Okay, now just log in my project again. Okay, plus play button and run mode and exit. Okay, and go to system exit. From here, sorry, from here, system exit. Okay, so let's go to see our safety project again, and here safety group, and monitor it. Okay, it works. I don't know, but maybe some download process problem. Okay, so at least it worked now, and you see that I get the input signal. Okay, finally I will turn on the camera to show you with the machine. Okay, so let's turn on our camera. Okay, now I turn on the camera and I turn on the Firefox, and you see there's the web server of our Schmersal module, and I forgot to tell you how to set the module, the EOE, Ethernet over Ethercat driver. You can go to Ethercat, go to the module, and then advanced setting and mailbox EOE. Then you can set the IP address and different to use or not use your web server in here. Okay, so no big matter. And okay, so in here you can see the date, the state. You can go to home page. You see actually the operation temperature and the IP address or everything, any error or not the FSoE address something. And you can go to Analytics to see is there any error of your port. Then you have this state device port, and you can just maybe a little bit slow. I think it's because my computer problem. Then you can see the status of each port. Then you also go to parameters. Although you cannot change in here, but you can view the parameter for all the port in here. Okay, but it's not a big problem. Okay, and now I go back to camera side in here. So here's the camera. Oh, let me turn on the safety group first. Okay, just something like this. And I put my hand here. Then you'll see the safety signal will be turned off. And then I put my hand out. It will turn on again. And also for the e-stop signal. Now you see the lamp is working. Okay, let's see. Great. All the operations is normal, and you can see the signal change from on to off or from off to on. So I think the tutorial here is enough. So thanks for watching my video, and sorry about my worse English, and I hope I can see you in next tutorial. So please have a good day. Be safe. Bye bye.